video, we will learn how to answer this question, and we'll use Excel to help us with that. Let's begin by reading the problem. The following table shows retail sales in drugstores in billions of dollars in the US for years since 1995. So there you see the column of years and the column of retail sales in billions of dollars. The years are actually not years, but a number of years that has gone by since the year 1995. And this is data that is presumably collected from actual things that happened. So 0 years since 1995 would represent the year 1995. And so what we're looking at here is that in 1995, there was $85.85 billion in retail sales in the US. And for 3 years after that, in 1998, we saw $108.426 billion, and so on. However, knowing that we have those pairs, maybe that's not enough information. Maybe we want to try to use those pairs, plot them on an XY coordinate plane like this, and see that they have a linear shape to them. And so we try to fit a line to those dots the best possible way we can to minimize the amount of error that we would make by using this line to make estimations. Now, we have seen videos where I've walked you through how to actually take this data, copy it and paste it into Excel, and do a scatter plot yourself, and find the linear regression equation yourself and the linear correlation coefficient. So that video is useful for some problems, but for this particular problem, they've actually done that part of the work for us. They've given us this linear model here. So they've already done the work. Now, if we take this set of numbers and make a scatter plot and do the calculations, we would come up with this same scatter plot and this same linear equation using the least squares method. So we don't have to do that part, but we're going to use this information. So let's go on and read what they want us to do here. We're being asked to use the above scatter plot to decide whether the linear model fits the data well. So just by visually inspecting this scatter plot and the line graphed on it, we see that the line looks like it's fitting the points very well. So we would say, according to just looking at that, we'll say that this is a good model on only that much information. Next, we read, estimate the retail sales in the US in 2015. So we want to come up with a number of billions of dollars that we think would have been the amount of retail sales in that year, in billions of dollars. So how can we do that? We're going to use the linear model. So here's the linear model, and I'm going to copy that. And then I also need the year, 2015. Okay, so models the dollars, billions of dollars of retail sales in the US T years after 1995. Okay, so T represents the number of years after 1995, and F of T is function notation, if you remember that from algebra, which just means, in a simpler way of putting it, Y equals all the rest, because the function notation is another way of saying the Y value that corresponds to the given input value. And the input value, we traditionally usually see it as X, but here we're using T for time. So I'm going to replace that F of T notation with just Y and let that be my retail sales. But another thing, Y just like that really is the notation we could use for the values in this column because those were observed in the population. That was actually data that was collected and actually happened. But what we want to do is find some estimates. So let's differentiate this y from something that actually occurred, and we're going to call it y hat. Now, I usually spell it out in Excel just because it's a little faster, but you can also go ahead and do an equation and use the accent feature to create the proper denotation. So it's y with a hat on it equals, I have to get out from under the little hat there with an arrow, and then equals 9.44 t plus 84.182. Now, maybe this is starting to look familiar to you if you've ever used slope-intercept form of a line. And that's what we see here. That's what's making that line equation for us. I meant that to be a point there. All right, so we're going to go ahead and use this to make some estimations. So when we have t equals a certain number, we're going to plug it in, replace the t in the linear regression equation, and just simplify it to find the corresponding number of sales. So now what is t? Well, we know that we want to estimate the sales in 2015. So then what would be t? T is the number of years that have passed since 1995. So we can find that by taking 2015 and subtracting 1995. And so you'll come up with, if you want to do the calculation right here in your Excel spreadsheet, you can do that. Remember, Excel, every single cell is a little calculator. You can do calculations by just starting with an equal sign. So when I put in 2015 minus 1995, you see I get 20 years. Okay, so I'm going to take my, I'm going to come up with my y hat by taking the slope and multiplying it times t. So equals 9.44 times 20 plus 84.182. So there's the amount of money that we would have made in that year in the US in billions of dollars. Okay, so let's go ahead and take that answer and submit it here. Make sure that you're always watching out for any rounding directions. This just says enter your answers as an integer or a decimal. So I'm going to press enter, and we got it right. Okay, so no big deal. Just plugging in the number of years that have passed. Now, you can also do this as a relative reference if you want. Instead of typing in the 20, you could have typed it in this way, 9.44 times this cell, which contains our t value, plus 84.182. And the reason this might be useful is if you did a similar example and you were given a different answer, then you could just change the number of years and automatically get a new estimate. Just a little thing you can try doing if you want. Now, there is another part to this question. So let's see. It says use the model to predict the year in which retail sales will be 231 billion. All right, so we're going to use that same model, but this time instead of looking for the retail sales in billions of dollars, okay, I messed that up. Let me undo it. I'm going to format this as currency dollars, billions of dollars. Well, that doesn't really work because I want it to be billions of dollars, but I'm going to leave it alone and move on. Trying to be too clever here. All right, so what we want to do this time is the other way around. They tell us the number of dollars and billions of dollars, 231 billion, right? So they're actually giving us a y value, 231 billion. What is the year that this would happen in? Okay, so since t is the year, let's take that original equation and solve for t. So I'm just going to let it be y equals 9.44t plus 84.182. Okay, and I'm going to solve for t because this time I want to estimate t. So we're going to actually get t alone, and we're going to have t hat instead of y hat. We're going to make an estimation of the number of years that would have passed. Okay, now can you remember solving equations in your algebra class? Let's see if I can draw this out for you a little bit here. Okay, so y equals 9.44t plus 84.182. And to get t alone, I can do inverse operations, undo this addition here, and of course we know that anytime you do something to one side of an equal sign, you have to make sure to also do it to the other side in order to keep everything balanced. So just like I will subtract it here to zero it out, I'm going to also subtract it from the other side. So like that. Okay. And so then I have a resulting equivalent equation that looks like this. Okay, and we still want to get t alone, so we just have another operation to invert. We have multiplication occurring between the t and the 9.44. So we're going to go ahead and undo that by dividing to get the multiplicative inverse, which is 1. And we'll do that over here also. And so now we have t hat is y minus 84.182 divided by 9.44. Okay, so now we can take that and plug in a number of billions of dollars for y and come up with our estimated number of years. Okay, so I'm going to do that right here. I'm going to take the, what did they say, 231 billion? Okay, so I'm going to take 231 billion minus 84.182 billion divided by 9.44. And so I get about 15.55 years after 1995. Okay, so I'll take 1995 and add that number of years and find that I'm in 2010. Let's try that out here. All right, and that finishes that question. I hope that helped. Let me know.